Hey guys, welcome to Outpost 95. Thank you for joining us today. What we're going to be going over is the highlights of the Universal Transverse Mercator coordinate system, so that when we begin plotting points on our maps for navigational purposes, you'll be able to understand what we're talking about. Alright, what is the Universal Transverse Mercator, or UTM? Basically, it was a way of making a flat rectangular map for a not flat rectangular Earth. It was developed in the 40s. From the military, an early version of what we call the Military Grid Reference System, or MGRS. I think it's a slightly better system, but we're going to use the UTM because it's not as easy to get MGRS maps versus our USGS maps. They come pretty much ready to go with the UTM coordinates. The cool thing is, once you learn either MGRS or UTM, it takes very little time to transition from one system to the other. They're basically the same. It's just when you start getting on the big areas there'll be a difference. All right, there's a couple small issues with the UTM, and that's why MGRS was made. Going over distances of 100,000 meters is kind of difficult to relay that information because the way the numbers line out. We'll show you a little bit later here. And you could also have the same coordinate in the north and the southern hemisphere. So that's a big deal for the military guys, which is why they came out with the MGRS. Okay guys, we're going to try and break down the UTM coordinate here. I've got a coordinate at the bottom. Show you right there. Alright, there's going to be a UTM grid zone. That's kind of where in the world. And that's going to be, in this case, R11 uniform. You're going to have your 60 longitudinal zones. That's going to be going up and down. These are going to be measuring east. You can see that they're starting with a 0 here and with a 60 here. You're going to have 20 latitudinal. So starting here and going here. These are running parallel to the equator. And they're going to make little grid squares or little boxes here. And then each grid zone is broken up into your 100,000 meter grid square identifier. And the identification in our coordinates is going to be the 5 and the 53 in this particular case. And then your grid coordinates themselves, that's going to be these 5 numbers and these 5 numbers, which would be a 10-digit grid coordinate. You can have 4, 6, 8, and 10 grid digit coordinates. Okay, like I just talked about, you can have 4, 6, 8, and 10-digit coordinates. This is some stuff that you're going to want to remember so that you can kind of know with what degree of precision that this UTM coordinate is in. A 4-digit coordinate is going to be accurate to 1,000 meters, or it's going to cover 1,000 meters or 1 kilometer of space. You add a 0 on each of the halves, giving you a 6-digit coordinate. That accuracy is going to go up to 100 meters. 8 digits, 10, and this is about as accurate as you can really navigate in real life. You can't get 1 degree accuracy off map and compass just because the scale is too small for that level of precision. Your 10-digit coordinate is usually how it's going to be given, especially if it's off some GPS software. That's accurate to 1 meter. Most GPS monitors or GPS machines, they're not even accurate to that based on the sensitivity that the powers that be currently have your GPS set at. That's something that can be adjusted, and that's because it's military technology, and sometimes they don't want everybody having super precise coordinates. All right, we're going to talk about reading a coordinate. When you read a coordinate, you're always going to read right and then up. Right being your easting, and then up being your northing. You've got here on your map a number, a little 5, and then a big 47. That little 5 here on your easting, and then your big 47. So you're going to go over here to your 47. You know you're in the right place. Now you need to find your up. We got a 5387. your 53 and your 5, they're your 100-meter grid square designators, or 100,000 meter grid square identifiers. And then your 87, that's your up. So if I'm going to go right to 47, I'm going to go here, I'm going to go up to 87, I'm going to go up to this line here. And we're going to be talking about everything that's located in this grid square, and this grid square is 1,000 meters. The precise location of this coordinate, because everything after is zeros, is actually going to be at the intersection of these two lines. If we took a 0 off of the 47,000 and the 87,000, that would make us an 8-digit coordinate. If we remember correctly, our 8-digit coordinate is 10 meters, about as accurate as we can use navigating on foot, and that's the world we're going to be living in when we're doing map and compass work here. That's going to be 10 meters starting in this bottom left-hand corner here of 47 right, 87 up, going up 10 meters, up 10 meters, back, and making a little tiny square. Continuing on, if we took 2 digits off of here and 2 digits off of here, we now would have a 6-digit coordinate, 470 and 870. If we remember right, or from our last screen, a 6-digit coordinate would be 100 meters. So we'd go out 100 meters, or 1/10 of this square, up 100 meters, and then back over. And everything inside of that would be accurate to our 6-digit coordinate. Lastly, if we had a 4-digit coordinate, which would just be a 47 with no zeros, and an 87 with no zeros, we'd still be starting here at the intersection, but it would encompass this entire grid square. So if we were talking about a mountaintop and it's at that 4-digit coordinate, you'd look for a name feature. We'll be going over that here in the future. Thanks for joining us today. I know that was really fast and we covered a lot of ground. So if you have any questions on all of that, let me know. And we'll be going over how to utilize this stuff here in the short future. Thanks for joining us. God bless.